Dan said, I'm Justin Smethers. I'm here today to present accelerating Python data analysis with DuckDB. DuckDB is a really cool tool I've been using recently for both at work and kind of for hobby projects. So wanted to do this talk to learn some more about it, but also, share it with people here because I think it's going to be very useful. So I'll get more into kind of how I use it towards the end after I talk about what it is. So we'll go over that then. First, a little bit about who am I? Like Dan said, I'm a business intelligence engineer with 3 years of experience. I've worked for 2 years at Best Choice Products and 1 year at Sweetwater Sound. Any musicians in the audience might know that, just big music retail store. New to the Ann Arbor area. I'm actually moving here this summer with my fiance here. So anyone that would like to show me around, let me know. Not too familiar. And I'm interested in all sorts of data problems. Being a business intelligence engineer, do a lot of data engineering, data analytics. Interested in doing some IoT device projects this summer with some Raspberry Pi, some large language model projects. So if anyone would like to collaborate, reach out and I'd love to work together. Kind of final order of business, like Dan said, I'm going to PyCon, so anyone that's going, please reach out. Would love to connect and have some people there to bounce off of and meet some other people there with as well. So all right, let's get into it. First, just an outline of what I'll talk about. We'll talk about what is DuckDB, why is it useful, getting started with it, just setting it up and just kind of the basics of it. Something called the billion row challenge using DuckDB, so really going from 0 to a billion there. DuckDB's integration with Pandas, since this is a data analysis talk, Pandas is kind of the go-to for Python data analysis, so only makes sense to show how they work together. And finally, DuckDB use cases with the demo that I'll show off as well. So let's get into it. What is DuckDB? Getting ready for this talk, I saw it referred to a lot as SQLite for data analytics. So for those that know SQLite, it's similar in that it's very lightweight, but optimized for data analytics workloads. So more for reading data and doing sorts of calculations on data. But more to the definition for those that don't know SQLite, it's an in-process analytical database. And I'll break down what that is. In process, meaning that it runs within the application. So when you're running DuckDB, it's not running on like an external server, external process or anything. It doesn't connect to anywhere else. It's running inside where the application is running as well. And it's an analytical database, which for those that don't know, analytical databases, they're optimized for those like SQL workloads for retrieving data, like aggregations and combining data sets. And aggregations meaning, it's optimized for very quick, like summing data, taking averages on numerical data, pulling out string data, those kinds of things. Combining data sets, it is very fast at like joining data sets together, even on large scales. It's also very lightweight, no dependencies. So when you install DuckDB, it doesn't have to install other libraries. So very little overhead to manage there and very easy to get started with it. And just a graphic here that I'll show off as well. This is a chart of just different databases. This comes from a research paper that introduced DuckDB. If you see that citation down at the bottom, it was actually created by a pair of researchers from the Netherlands, I believe. And they wanted it to fit in that intersection of embedded databases, so very lightweight, very fast, but built for that analytical workload. So, and not too many other databases kind of in that niche, so it's kind of filling that gap there. And those two researchers that introduced it still work on it today. I forget which year they introduced it, 2018, I want to say, but they're still part of developing it today. But maybe more importantly, why is DuckDB useful? Really two things. It's fast and it's simple to use. It's fast because it stores data in a columnar format. So data is stored in columns rather than row by row. So that way, when you retrieve data, you're retrieving just the columns you need, and it can optimize, getting that data a little bit faster. It also does vectorized operations. So rather than operating on single pieces of data at a time, it can do operations on batches of data. So it just speeds up those things like aggregations and can make that go a lot faster. Also, being simple to use, it's very easy to set up. Like I said, with having no dependencies, it's just very simple installation. And again, in process, you don't have to manage connections to any external servers or external processes to use it. So getting started for Python, it's just a simple pip install DuckDB. And that's all you have to do to get everything installed for any scripts. And then you're ready to start querying data with SQL. And I'll go over a little bit, just a quick primer of SQL for those that haven't used SQL before, knowing this is just a Python talk. Some people might not know so much. So really just go over some, enough to get started with SQL, which is just a couple keywords. The first being select. When you're writing a SQL statement, you select which specific columns you want to use. So in this, we're getting column 1 and column 2, just some fictitious arbitrary column names. You can also do aggregations here. So you could sum column 1 here, but I'll pull that away. You do from a table name, so a specific table, specific data set, you're specifying that there. And then where, which is just a filter. So in this, we're selecting column 1 and column 2 from a data set called table name, where column 1 is less than 10. So just some simple SQL that's really all you need to kind of get started with it. So as I talk about it, you'll see that come up. So to show getting started with DuckDB, I'll show how to create a database with it in Python, how to insert a table, and how to query data from that table. So I've got a code snippet here. You see I'm importing DuckDB at the top. This first line is just connecting to an in-memory database. So being in memory, you don't have to create a database file or even persist anything. It can just store data in process. Alternatively, this next set of lines, I connect to a database file. Here it's called my database DB. So you can persist a database after you finish running the script that will be there with like the same tables that you have in there. And then down here at the bottom half is where we're actually working with data. So this next section here, where we're creating a table and inserting data into it, creating a table called students with a column name and grade. And I'm inserting values of just student name Alice with a grade of 9.0. So once you do that, you have a table in the database with that data in it. And then you can execute in the final lines of this code here is a select everything from students. And so once you run that, you just see the simple Alice and 9.0 that we just put in there. So simple enough to get started there. Moving a little bit farther to working with CSVs, because in day-to-day, you're probably going to be working with CSV files most often. We're going to export that table I just created to a CSV and then query directly from that CSV file. So using that same students table, I'm doing a copy command to create students.csv, which will just have that one row. And then on this second half here, I'm doing select everything from this read CSV function. So I'll note here as well, you can read directly from the CSV file. You don't actually have to create a table. You don't have to do any insert the CSV into it. It just allows you to read the values directly from it without having to do any other management there. So when you, here's that CSV that it creates. This is the students.csv file. And then when you execute it, you get the same thing as the last side. So super simple getting started there. Move on to something a bit bigger. So we'll show off why DuckDB is useful here with something called the 1 billion row challenge. I'll get into exactly what it is in a second, but in this, we'll be comparing the performance of 3 different Python libraries, Pandas, Polars, and DuckDB. And again, I chose Pandas because it's essentially synonymous with Python data analysis. So if you're doing any sort of Python data work, either in a class setting or in a workplace, often you'll encounter Pandas. If you're not familiar with Polars, it's essentially billed as accelerated Pandas. So it's the same kind of data framework that Pandas is, but built in Rust. So meant to execute a little bit faster, a little bit more efficient memory optimizations. So a little bit faster there. So we're going to see how those libraries perform against DuckDB in this challenge here. And also I'll note I made this image with Dolly. Just thought it was funny of a panda, a rubber duck, and a polar bear pouring over a spreadsheet. So kind of, image of what's to come. So what is the billion row challenge? It was created by a Java engineer, Gunnar Morling. Excuse me. The task is essentially to perform aggregations on a CSV file with fake weather station names and decimal measurements. So I'll show a sample of what it looks like here, which is just this CSV file with 2 columns. Like I say, the left column are those fake weather station names. And the second column are just decimal numbers, positive and negative. It's just this a billion times over. So just lots and lots of rows of weather stations. And originally, Gunnar put out this mission statement, write a Java program because he's a Java engineer. Write a Java program calculating the minimum, mean, and max temperature per weather station. There's just one caveat: the file has 1 billion rows. And as part of this challenge too, you're able to generate CSV files with as many rows as you want. So I did it with 100 million rows, 250 million rows, kind of going up. So we'll go over how each of these performed there. Just for reference, I ran this locally on my desktop at home. So these are my computer specs, 32 gigabytes of RAM. So if you run it yourself, you might experience some different time for how quickly these can process the data. So getting into it. First, we'll start with how Pandas did on this challenge. I'll show the code snippet here, and I'll kind of go over it for anyone that might not be familiar with Pandas here. This top part here is setting up our Pandas data frame, where we're reading in this CSV file from file path. We're setting up the column names and data types, and where we're really getting into the aggregations is this bottom half of the file here. So we read in the CSV using the specifications we just made at the top, where we're specifying the, again, data types and column names, and doing the aggregations here. And I'll note first too, this start time and end time, I timed how long each took to read the CSV and perform the aggregations. So the aggregation here is we're grouping by the station name, performing the minimum, maximum, and average of that measurement column, and then returning the data frame sorted by station name. So you're returning an alphabetically sorted list. So how did Pandas do? First, I did it with 100 million rows, and on my computer, it took Pandas 40.7 seconds to process those 100 million rows. For 250 million rows, it took about 108 seconds to process those. And then at 500 million rows, I ran into a memory error and killed the process on my PC. So that was as far as I got with Pandas. And just to note, I'll show a comparison at the end of each of all the libraries with each other. So don't worry about memorizing all these. I'll show them together at the end. So polars. The code looks pretty similar to what Pandas is because, like I say, it's billing itself as a faster Pandas. So that same data frame type code where at the top here, we're specifying the file path, the column names, the data types. And this bottom half is where we're actually performing the operations. So we're reading the CSV in very similarly to Pandas here. And then same with the aggregations, grouping by station name, getting the minimum, maximum, and average values of that measurement column, and then returning that alphabetically sorted list by station name there. So how did polars do? For 100 million rows, it took 7.2 seconds, so already significant speed up on what Pandas was able to do. For 250 million rows, it was about 47 seconds. And once again, it killed at 500 million rows, so that seems to be the blocker here for these. But significant speed up from Pandas in terms of that 100 million row and 250 million row performance there. But we'll get into DuckDB now. So this code will look a little bit different because with DuckDB being an analytical database, the queries are executed with SQL code. So instead of working with data frames, you have to write that same operation in SQL. So this is, if you're especially comfortable in SQL, this will look, familiar there. In SQL, the query is written where we're doing, we're selecting the station name here. We're once again selecting that minimum, maximum, and average of the measurement. This from specifies where we're reading from the CSV. So here we're reading directly from the CSV again, with those same column names and data types in there. Grouping by station name and returning the alphabetically ordered list. And then the bottom half, this is where we're actually executing. Once again, we're connecting to an in-memory database and executing the query on this last line here. So how did DuckDB do? Jumping through those files, we see it already does significantly faster here, where with 100 million rows, it does that in 2 seconds. 250 million rows, it does that in 7.5 seconds. And it was able to do the 500 million rows in 15.4 seconds. It was also able to do the billion rows. So on a billion row CSV, I was able to perform this calculation in 30 seconds flat on my computer. And just to see how far I could push DuckDB, I tried it with 3 billion rows, and it was actually able to do that on my PC in just under 90 seconds. So you're able to do a lot more data for this type of operation using DuckDB over data frame frameworks like Pandas and Polars. And just a note here as well, I wanted to note the file size of this 3 billion row CSV. On my computer, that was 44.2 gigabytes, which if you remember I mentioned earlier, my computer has 32 gigabytes of RAM. So DuckDB is actually able to process more data than there is RAM available. And that's just through some different memory optimizations that are kind of technical, but I didn't actually know that until I was putting this talk together. So it was really interesting to see how much data it could actually process. So here is the comparison of those together. This graph here we have on the horizontal axis is rows processed in billions. And so the vertical axis is the amount of time it took to process those rows. And just to note as well, the gray vertical lines are where I actually ran, the operations. So like for DuckDB between 1 billion and 3 billion, I didn't actually do these aggregations on like 2 billion, 1.5 billion, anything like that. So just to note that. But at the top here, we see Pandas, taking its 40 seconds and 108 seconds on 100 million rows and 250 million rows. Polars with the significant speed up time there, and DuckDB doing even faster from there. And to note as well, DuckDB was able to do those 3 billion rows in just under 90 seconds, which is faster than Pandas was able to do the 250 million rows. And I'll say as well, this is definitely skewed in DuckDB's favor. Being an analytical database, it's really designed for these, those aggregation type operations for retrieving the data in this way. So it's really perform on this type of workflow here. So moving on, we'll get into DuckDB's integration with Pandas. And I wanted to show this again because, like I say, if you're doing data analysis in Python, you're probably doing it in Pandas. So it makes sense that when you use DuckDB, it's essentially a drop-in integration with Pandas. So you're able to query directly from a data frame. So showing off this code snippet here, I'm creating a Pandas data frame here, essentially just recreating the weather data set we just had. So a station name and measurements for each of those stations. And then using DuckDB, you're able to query directly from that Pandas data frame. So you don't even have to create like a DuckDB object. You can just reference the data frame variable name and put that in the from statement there. So very easy to drop in and do, these operations that DuckDB performs better on. It's easy to do those in DuckDB instead to get that performance boost there. Oh yeah, and when you execute that query, it just pulls those numbers. For this, it's the same values for min, max, and mean because I only put one value in for each, but just to show what you get if you execute this query. And just another code snippet of just some other things that it can do, since with DuckDB you can perform joins, aggregations, and other operations. So if you have in Pandas 2 different data frames, this is weather stations and measurements in separate data frames this time. Using Panda, I'm able to join these data frames together down here in the join statement, where I join measurements to weather stations. And then you get those same values that we saw in the last slide as well. So very easy to use DuckDB with Pandas without having to refactor any code to really change up what you're doing there. So finally, getting to DuckDB in the wild, or some use cases. We've kind of already seen data analysis and data cleaning and transformation with DuckDB. If you're working with CSVs or working with any sort of file format, you're able to pull in that data and use SQL to transform the data, do different calculations on it. Also ETL pipelines. This is something I use for work. Like I mentioned before, I use this for a lot of data analysis, especially. Just today, I was spinning up some local development data analysis using DuckDB and DBT, if anyone's familiar with that. But also ETL pipelines, where since it does very well at reading CSVs, also Parquet files and some other file formats, it's very easy to pull files down into DuckDB and do any work you need to inside of that before, say, pushing it up to a database or whatever process you need to move files around for. Also very good for embedded analytics, since it is very lightweight. If you have an application that requires some sort of analytics in it, whether that's calculating data to further process, or if you're just displaying visualizations, data analysis, DuckDB is very good for that. And interactive dashboards, which is a demo that I'll show here as well. Say using a dashboard framework like Streamlit or Evidence, which allow you to create just interactive visualizations that DuckDB can do, like the queries on the back end. So you get that interactivity as you change filters and whatnot in the dashboard. So I can show off a demo with that. So I'll show a quick demo with DuckDB and Streamlit. If you're not familiar with Streamlit, don't worry, I won't get into that really, unless someone wants to see the code in the end, I can pull that up. But it's just a dashboarding framework that, like I say, allows you to build visualizations and use DuckDB to calculate, changes in queries as you change filters and whatnot. So you get that interactivity on there. I'll show a dashboard using New York City taxi trips data. I pulled this down from just the New York City government website. They provide taxi data month by month, where just each row is an individual taxi trip one way. I pulled the January 2024 data, which is roughly 2.1 million rows and 255 megabytes. And looks like this, where it's just kind of a data you might expect from a taxi trip, where you have your pickup time and drop-off time, you have your passenger count, trip distance, fare amount, etc. So that's the kind of data we'll be working with here. So here I'll actually switch over to the so just pulling up the demo here.
So
Okay.
I think on the line, we just see your presentation.
Oh, am I just sharing that slide? Okay.
Yep.
Let me switch over my screen share. Okay, now I'm just sharing my screen, so should be able to see that, right? Okay. Bigger, and we'll zoom in here. Okay, so in this, I'll show an interactive dashboard. This one I built using DuckDB, like I say, to calculate those queries as I change these filters. I'll also show off an identical page that I built using Pandas instead. So to show off that difference of using DuckDB versus something like Pandas. So in this, a couple different parts of this dashboard. At the top here, we just have some filters. So in this, like I say, with New York City data, this is the boroughs of New York City. So you can change what areas of the city you're looking at taxi trips. And as I'm picking these and dropping them off, you see this running at the top. That's where it's recalculating based on those new filters in there. We also have a week filter. So this is looking at week by week, the number of taxi trips. So in this first part here, I'm calculating the maximum and minimum fare amount in this data set. In this, we find the maximum fare amount is just around $1,600, and the minimum fare amount is minus $700. So probably some data cleaning needing to be done there. Maybe it's a refund, or maybe it's some accident there. So if we were doing further analysis, we'd probably go in and clean the data set. This is all the query that's used to generate that, which is just selecting that maximum and minimum value. And the second part of this is creating a heat map of the number of trips in the city by hour and by day of the week. So each of these squares represents, turn off dark screen. Each of these squares represents like a heat map of the white squares are more trips and the dark squares are less trips. So just kind of looking at this to see, if we were doing data cleaning, do we need to shift the time zones or anything like that? We see here, most of the trips, it picks up early morning on weekdays, and again in the evening on weekdays. We see this weird blip here. This vertical, the zero here is midnight. So we see a lot of trips on Monday at 2 a.m. But if we look up here at the top, this is on New Year's Day. So lots of taxi trips at 2 a.m. on New Year's morning, people leaving parties or something. And I show here as well the query used to create that. And this shows at the bottom here. I also showed the amount of time that it took to generate this page. So this one this is using, right? So this is DuckDB one. Okay, so the DuckDB one took 4.59 seconds to load this page. So when it's loading, the calculations to, when it's calculating the data for this heat map, when it's calculating the minimum and maximum up here, that took 4.59 seconds. So now we'll look at the identical page using pandas. So that same thing, minimum and maximum fair, with this difference in code here, because this is the pandas code to get the maximum and minimum here. Same thing, heat map is looking identical to the other page here with the pandas code needed to generate this instead. And for pandas, that took 8.24 seconds to render this page. So even on just this data set that's 2 million rows, you already see, a couple second difference in generating this dashboard. So say if you're if you're in a case where you need to build a dashboard for some people at your company, end users that you're trying to show some analysis, they might already feel the difference between using something like pandas versus using something like DuckDB. So very well suited for this kind of use case here. And then we'll go back to this. And from there, we'll wrap up. So just go over quickly what I talked about here, and we can get into some questions if there are any. We talked about what is DuckDB and what makes it useful, which is primarily its speed and its simplicity. Showed off its speed with the 1 billion row challenge of aggregating 1 billion row CSV. Showed off DuckDB's integration with pandas and a couple use cases with a demo of the interactive dashboard. So with that, any questions?
Thanks, Justin. We had some questions online. Jay, hey Jay, does it support constraints like triggers or assertions?
I'm not sure, honestly. I know I would think so. They're looking to make it. There's actually a company, Mother Duck, that's building a cloud database on top of DuckDB that's making a full, feature-rich analytics warehouse. So I think there you might find something like that, especially, but I'm not sure with DuckDB specifically.
Great, thanks, Justin. Peter, hey Peter. He loved the time labels on your performance graph, and he was wondering how you plotted that.
Oh yeah, that actually it was just an Excel graph that I pasted into PowerPoint and just deleted the axes and played around with the points and lines there. So a very massaged Excel graph.
Nice. Mitchell, hey Mitchell, is asking, did you try the billion row challenge with DuckDB with pandas integration?
I did not. That would be interesting. I think one thing with how I was measuring the performance of them against each other was both the time it took for them to read the CSV and the time it took for them to process that CSV. So DuckDB also has an incredibly fast CSV reader. So that's definitely a big part of the performance. So if you did it with the integration where you read the CSV with pandas and then process it with DuckDB, first you might run out of memory, I guess, for especially for the 3 billion row file, but it would be a just slower overall time.
And Peter, I have one more question. Are you using Streamlit in your presentation, and can you show us how that looks in your code with the DuckDB info?
Yeah, pull that up. Yes, so this is the script I use to generate that Streamlit app. It is just DuckDB, Streamlit, and Plotly for the charts. I'm not super familiar with Streamlit, so I really wanted to get into it some more using this project, so I'll be exploring it more after this. But it is, let's see here. Streamlit allows you to kind of generate dashboards in this script manner where you don't have to do a lot of just more complicated scripting of like different classes or anything like that. Like all it is just these chart elements. I think they call them elements, that like your multi-select box for filters, select box for other filters, the queries in here, using the different using the values from the filters here. So selected borough comes from this filtered up here, that is then put into the SQL query that goes into DuckDB that I execute here. And then it's let's see here, written into the page using this st-write. So really pretty simple to go from either Pandas or DuckDB. It actually, you have to pass the data into Streamlit using data frames. So these fetch df functions here convert the result back to a data frame. So processing is done in DuckDB and then converted to a data frame.
Thanks, Justin. That looks pretty straightforward, so that's nice. Anyone else have any other questions about anything?
I have a
Hi.
quick question.
So, are there any
Go ahead.
blog posts or white papers as to how DuckDB achieves the performance it does?
They have quite a bit, really. They're really pretty good about just, well, media, I suppose, of putting out. They have lots of blog posts. They have a very good YouTube channel with several tutorials of like applications of DuckDB. Not sure about the white paper specifically. I know for like what I showed with the 3 billion row file, where it was able to do the 44 gigabyte file on my 32 gigabyte RAM machine. I know there's a lot written about that, so I would say it's easy to find a lot of things around their performance. I'm not sure about the white paper specifically they have, but their documentation is very good and their YouTube channel is very good.
Any other questions?
Yeah, I have a quick question. The in the beginning, you mentioned something about that it's column oriented and versus rows. I don't know if I heard you correct.
Yes. Yeah, I'm not sure all of the inner workings of that. That's typical of analytical databases. So not just DuckDB, but if you're working, in the cloud, like a BigQuery or Snowflake, store data in column format. So it just makes it easier retrieval for, where when you're selecting columns, it only has to get the columns you're selecting, where in a row-based format, you might have to get the rest of the data and then pair out the specific columns you're selecting from there. So it's just a way to speed up analytical queries like that.
That's kind of confusing because rows are usually the records, of each, let's say each weather station.
Mhm.
Normally in an SQL table, the rows are the records and the columns are the individual, data elements.
True here too.
I couldn't hear you too much at the end there. What was that at the end?
I was saying that the usually the rows are the records and the columns are the fields or data elements, whatever you want to call them.
I guess I'm not.
So I'll have to look that up to see how it's.
Yeah. That gets at kind of the inner workings of how I guess they keep
Mm.
Specific rows together. Then, I'm not too sure about that, but
Yeah.
I think still the rows of the records is just the column database lets you select only part of the data, right? So you're only like using like one column at a time, and it can do that selection like really fast. I think that's
Okay.
yeah. I don't think it's like inverting the columns and rows or something like that.
Oh, okay. So it's just you pick certain columns and it's like selects every record.
Yep, exactly. Any other questions, anyone?
Well, anyway, I mean, yeah, it's faster than normally in a database. I would like split the columns just for the data I need. And then, take them apart, separate them, two tables, and then do the query. Here, I guess you don't have to do it if it's set up this way. Unless you're importing data from a different table, then that still takes time.
Yeah, and once if you import it into DuckDB, then it will be stored in that column format. So
Right.
just depends where I guess you're doing your operations, where you'll get that efficiency. But once it's in the database, it'll be stored in that way.
Yeah, and it's great for online analytics, like you showed the Streamlit.
Yeah,
Mhm.
definitely.
Any other questions, anyone?